In this demo, you'll see how to quick start customize and deploy a fully functional RAG pipeline using Ragbits within minutes and complete with ingestion, retrieval, and a working UI. RAG is one of the most impactful applications of LLMs. It can help you query your custom set of structured and unstructured data, synthesize information, and even perform advanced reasoning. There are many ways to do it, including SaaS-based solutions from major tech players. There are reasons why you may want to set it up on your own, on-prem, and using open-source components. These include compliance, data confidentiality, or simply more control. At deepsense.ai, we build highly customized applications that leverage LLMs for a wide range of use cases. To streamline development, we created Ragbits, a modular set of building blocks for rapid LLM application deployment. This enables us to launch AI solutions in minutes rather than hours or days. After proving its value across numerous client projects, we've just released Ragbits 1.0, a stable production-ready version available for broader adoption. Ragbits help you set up your RAG application quickly using predefined templates and providing full customization and interchangeability of underlying tech, LLMs, vector stores, and a variety of data sources. In this demo, I will show you how to set up a RAG application for querying using Ragbits components to quickly get it running and even equip it with a simple UI. Let's get into it. We'll start by generating our project using the Create Ragbits app template. This gives us a ready-to-use starting point for building RAG applications. To generate the project, I'll run UVX Create Ragbits app. You can also use pip or pipx. This will automatically download and launch the generator. The first step is choosing a template. Right now, we offer a general-purpose RAG app template. More templates are on the way. I'll accept the default project name. Then we choose the vector database and document parser. For this demo, I'm selecting Qdrant for the vector store and Docling as the parser. The generator also asks if we want to enable hybrid search and image-based enrichment. Let's enable both. And that's it. The project has been scaffolded with source code, Docker files, pyproject.toml, and a README, all ready to go. Now that the project is set up, I'll switch into the new directory and install the dependencies. While that's running, let's take a quick look at the generated code. The components.py file is the core of the app. It wires together the LLM, vector database, embedding model, and the document search pipeline. This is where ingestion and retrieval are orchestrated, making it easy to customize your architecture in one place. Over in ingest.py, we define how and where to fetch our documents. In this example, we'll fetch the Mistral white paper directly from RxIV. Ragbits supports fetching documents from various sources, including the web, AWS, Google Cloud, Azure, and more. The ingestion pipeline will parse the document and store it in our vector database, ready for use in the chat. Now I will run the ingestion process. I will also add the Ragbits verbose flag to show me all the logs in verbose form. I will fast forward through this process to the end. Okay, the ingestion process has finished. As you can see, in Ragbits you have every component orchestrated with tracing, and you can observe every element and operation that happens under the hood. Apart from console traces, we can also send traces to OpenTelemetry and popular providers like Grafana Tempo. With the data ingested, it's time to launch the chat interface. The UI is powered by Ragbits Chat, which connects to our document backend and the LLM. You can use the default Ragbits UI for development, testing, or demos, or build your own using our TypeScript SDK. To start the app, I'll run Ragbits API run, and then open the browser to see the chat UI. Here's the chat interface in action. We previously ingested the Mistral white paper, so let's ask a technical question to see how well the system retrieves and synthesizes relevant content. I'll ask, how does sliding window attention improve computational efficiency in transformers? Behind the scenes, Ragbits retrieves the most relevant chunks from the vector store and sends them to the LLM along with our query. The model then generates an answer grounded in the content of the white paper. And just like that, we've got a working RAG pipeline, ready for deeper exploration or customization. Wraps up our demo on building a document-aware chat app using Ragbits. With its modular design and plug-and-play architecture, Ragbits makes it easy to prototype and deploy your own LLM-powered tools. On our GitHub page and documentation, you can find additional examples. We are constantly adding new features. For example, in the next release, Ragbits will allow you to create agentic workflows. Thank you for watching. Give Ragbits a try and start building your next AI application today.